In this video, we're going to learn about how the tool works and Region 1 of Vimom. First, we'll start the software. We'll pick Camera 1 first. Connect inside Camera 1. And wait for the camera images. We can see that the images here are from the output of a paper machine in a factory. We notice operators working in certain areas of the image. When we click on the tool list, we can see that Region 1 has 10 tools ranging from Region 1A to Region 1J. We can draw up to 10 different analysis areas within the same image. In our case, we'll select Tool 1A for the test. We'll draw the analysis region. Let's draw an analysis area in front of this machine, where we can see an analysis area has been created. This area can be rotated using this small circle and dragged by clicking in the middle of the ROI. For object monitoring, we recommend keeping the area properly aligned with the base and the type of object. In our case, we can see there's a slight tilt, so we'll keep the area slightly tilted as well. After drawing, we have the Start button and the Stop button. We have the button to start a momentary analysis without starting automatic analysis. Here we have the monitoring interval for automatic analysis. Here's the checkbox to activate or deactivate only. The tool works if this checkbox is checked. Here we have the confidence section, or, in other words, all objects with a confidence above 0.5 will be analyzed. We have a Gaussian filter here: low, medium, and high. Choose a bilateral filter option. Low, medium, or high. Pick one to boost your image if your camera's bad. However, it should be evaluated. We recommend starting with the default filter settings, both Gaussian and bilateral. On this side, with this button, we have the model selection. We have 4 selectable models: Model 1, 2, 3, and Model C1. As we increase the model numbers, for example, the models become the best accuracy compared to the previous model. However, it requires more processing. For example, Model 2 tends to be 30 to 50% heavier on the processor than Model 1, yet it's more accurate than Model 1. The same goes for Model 3. Compared to Model 2, Model 3 is currently the most accurate model. In the manual, we explain better how much processing each of these models requires. Model C1 has the same accuracy as Model 3, but Model C1 is trained in a way that we can train it in the training module. In this part of the box, we have the selection. We can pick up to 5 objects here. We know if there's an object or not. 0 for negative and 1 for positive. At Vimom, we work this way. the time we want to keep the output in milliseconds. If we set it to 0, the output is in real time. If we set it here, for example, set it to 1,000 milliseconds, outputs stay until 0. Stay at 1 for 1 second. And here, the number of objects observed within the ROI. In our case, we're going to run a test for a person. We'll select people as the object. Remember, the object list updates according to each model. Model 1 has its own object list. Model 2 has its own object list. Model 3 also has its own separate object list, and they're updated as we select them. The C1 model has the list of objects you trained in your model. Within your model trainer module, in this case, we only have 2 objects because this model was trained here as an example just for hand and head identification. But the identification training within the C1 model can be for any thing. Any type of object can be trained within VMOM using the C1 model. And the training module: objects, animals, plants, parts, anything with a shape. Image characteristics like defects in parts, fire, smoke, leaks. You can create various types of models within the C1 model. In our case, we'll first work here on Model 3, where we'll select here people. We'll start the analysis. Since we don't have anyone in the ROI, the value is 0, and the number of people here is 0. When someone enters the ROI, the values here will be updated and we'll wait for someone to enter the area. Let's analyze. When someone enters the selected area, the value changes immediately, as we can see. The person went under the paper. We'll wait for them to reappear in the selected area. As we can see, the person is being analyzed within this region. When the person leaves this region, the value here will be 0, and the number of people will be reset. These values can be observed here. They can be transmitted through the transmission module. They can be transmitted via a DB file that can be used with other software through of code line for reading a DB file. We can transmit the camera image with the observed ROIs. We can transmit them via OPC through Modbus. Using data CSV. to store the history, or via single-line CSV, or even through API. In our case, since we're working with Region 1A, we can select here. By result 1A and variable 2 will be the number of people identified. When we start the analyses, like if we start here with OPC 1A, Node 1 will confirm if there's a person or not, and Node 2 will be the number of people identified in the area. When we come back here, we can also observe that we can select other regions for simultaneous analysis. Let's mark Region 1B now in the area where the workers are operating, and we'll start the analysis with Model 3. Identifying people. We notice that the model is counting the number of people passing by in this area. The data from Region 1B can also be transmitted through the transmission, like the variable 1B. It corresponds to this item as the result of whether there's a person or not, and this item refers to the number of people. The map of these output names is described in the manual. The manual contains a general map of all possible outputs that can be transmitted from each tool. We can analyze various regions. For example, we can select another region 1C here. As we can see, we can set up logic according to each region of the machine or each region where we need to trigger alarms. This concludes the operation of Tool 1 of Vimam. But in the manual, there are more detailed instructions on using the tool.